Hello, hi everyone. Welcome to the Stone the Brand. This is our Siva sir. Now we are going to discuss about light reflection diffraction. Second part, that is lens. So we'll discuss about lens. So till now we discussed about mirrors. Now we will discuss about lens. Okay. So there are two types of lens: convex lens and concave lens. Convex lens and concave lens. Okay. So now you can see convex lens. So it's part of the spherical mirror. So here this is a part of the sphere. You can take a part of the sphere if you are adding these two. This is optic center. So here F1, 2F1, or we can also take C1, F2, F2. Here F2 we can take, and 2F2, and also we can take C2. Okay. I hope it is very clear. So once again observe here. So I'm considering a optic center F1, 2F1, F2, 2F2. Okay, and so optic center. So this is about convex lens. Coming to concave lens. This is a concave lens. Optic center. So here is F1, 2F1, C1. So this is a part of this sphere. So here I am taking F2 and 2F2, and also we can take C2. Okay, so this is about this is for convex lens, and this is a concave lens, convex lens and concave lens. Okay, now we will discuss about ray rules of convex lens and concave lens, and image formations of concave lens and convex lens we'll discuss. Okay, right. Convex lens. Optic center F1, 2F1, F2, 2F2. F1 to F1, F2 to F2. Okay. So object is placed at infinity, image is forming at F2. Object is placed at infinity, so I'm taking here. So after so object is at infinity, image is forming at F2. Nature of the image is real and inverted, and size of the image is highly diminished. Second one, this is about image formations. So now we are discussing, these are the image formations. Okay, so let's do it, no problem. So next one, So roughly I'll discuss lay rules, then we'll go for image formation. So optic center f1, 2f1, f2, 2f2. One light I am taking, after refraction it passes through focus. One light I am taking passes through focus. So second light I am taking like this. Optic center f1, 2f1, f2, 2f2. So another light I am taking like this. After refraction passes towards infinity parallel to principal axis. And next one, so we can take one more. I'm taking like this. Optic center f1, 2f1, f2, 2f2. So light ray is passing through optic center. No deviation takes place. Okay. So they will ask one question. What is the importance of the optic center? If the light ray passes through optic center, no deviation takes place. That is only important. So here you can observe first ray rule. Light ray is coming from infinity after refraction passes through focus. Second light ray is passing through focus after refraction moves towards infinity. Third light ray is passing through optic center. So it moves so undeviated. So it will not deviate, right? So these are the ray rules, and even for concave lens also same. Now we will discuss about image formations of convex lens. These are the image formations. Image formations. Now you can take here. So optic center f1, 2f1, f2, 2f2. So light object is placed beyond 2f1. One light I am taking like this. It passes through focus. So another light ray is passing through optic center. So beyond means between f2 and 2f2. So object is placed beyond 2f1. Image will form between f2 and 2f2. Okay. Okay. So here you can observe. Object is placed beyond 2f1. Beyond 2f1. Image is forming between f2 and 2f2. Nature of the image is real and inverted. And size of the image is diminished. Size of the image is diminished. Coming to third one, object is placed at 2f1. So I am placing object is placed at 2f1. So this is the optic center f1, 2f1, f2, 2f2. Okay. Object is placed at 2f1. Here I am placing the object. So where image will form? Okay, image will form at 2f2. Okay, I will do numericals also. Okay, so one light ray I am taking. So another light ray passes through optic center. Here to f2. Okay, so object is placed at 2f1. Image will form at 2f. Nature of the image is real and inverted and same size. So object is placed at 2f1. Image is forming at 2f2. Nature of the image is real and inverted. Size of the image is same size. Size of the image is same size. Okay. So this is about Once again, object is placed at infinity. So image is forming at 2f2. Object is placed at infinity. Image is forming at 2f2. Nature of the image is real and inverted. Size of the image is highly diminished. Object is placed beyond 2f2. Image will form between f2 and 2f2. Nature of the image is real and inverted. And size of the image is diminished. Compared to the object, image size is decreased. So object is placed at 2f1, image will form at 2f2, nature of the image is real and inverted, and size of the image is same size. Okay, so I hope it is very clear. So this is about okay, so image formations of convex lens. So 3 more image formations are there, so we'll discuss now. So at f2f1 completed. Now so object is placed f1 2f1 f2 2f2. Object is placed between 2f1 and f1. Here I have placed. So one light ray I am taking like this. So it will pass through focus. So another light ray I am taking like this. It will pass through optic center. Those light rays will meet beyond 2f2. Okay, object is placed. Object is placed between f1 and 2f1. Image will form beyond 2f2. Image will form beyond 2f2. Beyond 2f2. Nature of the image is real and inverted. Size of the image is enlarged. Compared to object, image size is increased. Coming to the fifth one. So here optic center f1, 2f1, f2, 2f2. Object is placed at f1. While I am taking like this, it passes through focus. Okay, so here so another light ray passing through optic center, those light rays will meet at infinity. Object is f1, image will form at infinity. Nature of the image is real and inverted. Size of the image is highly enlarged. Highly enlarged means, so image is forming at infinity. So the nature of the image is highly enlarged. Okay. Now sixth one is very, very important. Optic center f1, f2. So here f1, here f2, here 2f1, 2f2. Okay, object is placed at f1, between f1 and O. Object is placed between f1 and O. So image will form. One light I am taking like this. So it passes through focus. So another light ray is passing through optic center. If you are extending these light rays, okay, object is placed between F1 and O. Object is placed between F1 and O. Image is forming same side of the object. Okay, so image is forming same side of the object. Nature of the image is virtual erect. Nature is virtual erect and enlarged. Compared to object, image size is increased. Virtual erect and enlarged. Okay, size of the image is enlarged. Same side of the object. Same side of the object beyond to F1. Once again, observe here carefully. Object is placed between 2F1 and F1. Between 2F1 and F1, image is forming beyond to F2. Nature of the image is real and inverted and enlarged. So object is placed at F1, image is forming at infinity. Object is placed at F1, image is forming at infinity. Nature of the image is real and inverted and highly enlarged because image is forming at infinity. And here coming to the last case, object is placed between F1 and O, image is forming beyond, okay, so same side of the object beyond to F1. Nature of the image is virtual erect and enlarged. So this is about convex lens image formations. Now we will discuss about concave lens image formations. Okay, so be ready. Concave lens. Only two image formations are there. Optic center F1, 2F1, F2, 2F2. Okay. So object is placed at infinity. So I'm taking two light rays. So I'm considering. So here you can observe. F1. Object is placed at infinity. Image is forming at F1. Image is forming at F1. Nature of the image is virtual erect actually. So in this case we'll get virtual erect and diminished. Virtual erect and diminished, highly diminished because point size image is forming at focus. And the next one, so I'll discuss second one. Optic center F1 to F1, F2 to F2. Okay, object is placed so anywhere between optic center and infinity. One light ray is I'm taking, so it will be diverged. Another light ray is passing through optic center. So the image will form between F1 and O. Okay, so object is placed between infinity and O. Image is forming between F1 and O. Nature of the image is virtual and erect. Size of the image is diminished. So it's not highly diminished. Okay. Because so here you can observe only two cases are there. So always virtual erect and diminished image will form. So if you are considering a convex lens, real inverted and enlarged, real inverted and diminished, but in convex lens always virtual erect and diminished image, virtual erect and diminished image. So if you place, okay, virtual erect and diminished. So if you are taking the mirrors it will be reverse. So there concave mirror, next convex mirror, like that. Okay na? So opposite will be there. So in mirrors, what are the properties will be following for concave, convex? So it will be in convex lens, it will be reverse. There concave mirror means converging. Here convex mirror means converging. Concave mirror converging, convex lens converging. There concave mirror, convex mirror diverging. Here concave lens diverging. Okay na? So opposite it will be there, right? Yes. Now so we'll discuss next one. So refraction. So that is about lens image formations, everything we discussed. Now image formations of convex lens and concave lens also we discuss. Now we will discuss about refraction. Okay na? So how it will happen, everything we will discuss. Chalo. So I am taking this rarer medium and denser medium, rarer medium and denser medium. Light ray is coming from rarer to denser. So this is the normal line. Rarer medium and denser medium. Light ray is moving from rarer to denser, bends towards the normal line. So if it is moving from denser to rarer, it moves away from the normal line. So rarer medium, denser medium. So the angle between incident ray and normal line is called angle of incidence. Angle between refracted ray and normal line is called angle of refraction. So here, so the angle between incident ray and normal line is called angle of incidence. So this is the angle of incidence. And the angle between refracted and normal line is called angle of refraction. Okay. So now observe here carefully. Well, light ray is moving from rarer to denser, it bends towards the normal line. If it is moving from denser to rarer, it moves away from the normal line. When light ray is moving from rarer to denser, it bends towards the normal line. If it is moving from denser to rarer, it moves away from the normal line. Okay. So here if you observe carefully, rarer to denser, in denser medium, speed will be less. That's why it is bending towards the normal line. So in rarer medium, speed will be more. So that's why it is moving away from the normal line. So now we will discuss about Okay, so glass slab, when light ray is passing through the glass slab, how it will be? So we'll discuss. So incident ray. Hi, how are you? Bhavit, how are you? So incident ray, this is the incident ray. Incident ray, this is normal. This is normal. Okay. So this is a normal line. This will be refracted. So incident ray, refracted ray and emergent ray. So this dotted line represent. So initial direction of the incident ray, refracted ray, and this one is the emergent ray. Emergent ray. Okay, refracted ray. Refracted ray. This one is the emergent ray. And this is the initial direction of the incident ray. So the distance between emergent ray and extended incident ray or initial direction of the incident ray is called lateral shift. Okay, lateral shift. And coming to the vertical shift is nothing but, so normally if you are taking a beaker, so you place the coin at the bottom of the beaker. This is the coin. So you are standing here, you can't able to see the coin at this position. Okay, so you can't able to see the coin. After pouring water, so here you are pouring water, then the coin position appears here. The position of the coin here. So this is the apparent position of the coin. Apparent position of the coin. This is actual position, this is apparent position. So after pouring water, so we can able to see the coin. So this distance is called vertical shift. Vertical shift. So here lateral shift. So the distance between emergent ray and extended incident ray and initial direction of the incident ray is called lateral shift. Here vertical shift. Vertical shift is nothing but, so the distance between actual position to apparent position of the coin is called vertical shift. And here one more thing, even if you place the lemon also it appears bigger. Okay, so because of the refraction of light. And even if you place pencil, if you place pencil also it appears, even if you place pencil also it appears to be bent. So due to refraction of light, due to refraction of light. So this is about refraction of light through glass slab. Okay, so incident ray, refracted ray and emergent ray. So here the reason is when the light ray is moving from rarer to denser, so this is a rarer medium and this one is the denser medium, again denser to rarer. So if the light ray is moving from rarer to denser, it bends towards the normal line. If it is moving from denser to rarer, it moves away from the normal line. So the distance between emergent ray and extended incident ray is called lateral shift, and the distance between actual position to apparent position of the coin is called vertical shift. Okay, so this is about refraction through glass slab. Now we will discuss about power of lens and refraction also will discuss when it is moving from one medium to another medium, rarer to denser. If the light ray is moving from one medium to another medium, then the path of the light ray changes. The path of the light ray changes. That is called refraction of light. So if it is moving from rarer to denser, at the interference of the two media, it bends. Okay. So if it is moving from rarer to denser, it bends towards the normal line. If it is moving from denser to rarer, it moves away from the normal line. Okay, na? So the path of the light changes. At any way, the light changes at the interference of the two media. At the interference of the two media, path of the light changes. Okay, so that is about refraction of light. Now, generally, if light ray is passing from denser to rarer, so this is a rarer medium and denser medium. Rarer medium, denser medium. If the light ray is moving from denser to rarer, so normally what happens? It moves away from the normal line. It moves away from the normal line, right? Yes. Now you can observe here. So I'm taking like this. It moves away from the normal line, like this. So at certain angle of incidence, so this angle of incidence, at the angle of incidence, so the refracted ray passes or gauges or moves along the interference, or it makes 90 degrees with the normal line. That angle is called critical angle. Okay, so when the light normally if the light ray is moving from denser to rarer, it moves away from the normal line. So at the particular angle, at the angle of incidence, the refracted ray passes or gauges or makes 90 degrees with the normal line, then that angle is called critical angle. Okay, critical angle. Now same light ray we are sending. Okay, so from those positions, if you are sending one more light ray, I'm sending like this. So the light ray reflect back into the same medium. So this angle of incidence, so it makes more than critical angle, 90 plus theta. Okay, so if the light ray is moving from this is the rarer medium and this one is the denser medium. If the light ray is moving from denser to rarer, generally it moves away from the normal line. So at certain angle of incidence, the refracted ray passes or gauges or moves along the surface, then that angle is called a critical angle. If the light ray makes more than critical angle, then it will reflect back into the same medium. Okay, so that is about total internal reflection. Total light internally reflection takes place. So that is nothing but total internal reflection. Total light internally reflection takes place. Okay, so next one. The reciprocal of focal length is called power of lens. P equal to 1 by F. Reciprocal of focal length is called power of lens. The degree of converging or diverging of lens HOD is known as power of lens. P equal to 1 by F. Power of lens is positive for convex lens. Power of lens is negative for concave lens. Power of lens is positive for convex lens and power of lens is negative for concave lens. So this is about lenses, light reflection and diffraction. Okay, so mirrors already we discussed. So now we are discussing about lens. So if you like the content, if you like the channel, if you like the explanation, do like, share and subscribe to Study in the Brand. So this is your Shiva sir. Thank you so much for joining and attending learning my class. Do like, share and subscribe to Study in the Brand. Thank you.